Multiplying powers with the same base. All right, part one, review. Number one, all of these I want you to simplify. All right, x squared times x cubed. Who remembers what to do with this? And yes, you did this last year. Around this time last year, you had a unit on this. And the year before. Yes, Chauncey?
Don't you just add 2, 3, the x to this one?
X to the fifth. You add the exponents. Do you guys remember that?
Yeah, I remember that.
Yes?
Yeah. Oh, yeah, I do.
Yep. Why is that? Do you agree that x times x is x squared because there's two of them? Yes or no?
Yes.
Do you agree that x times x times x is x cubed because there's three of them? So if I had x times x for x squared times x times x times x for the x cubed, how many x's do I have altogether?
5.
So you add up the exponents. Is this clear?
Yes. Yeah.
All right, number 2. X squared raised to the third power. A power to a power. We're going to review everything today, and then we're going to break them up day by day. This is what we're doing today. These two, actually, because there's 2 lessons today. All right, number 2. X squared to the third. Who remembers what to do with a power to a power? Add or multiply?
Multiply.
You multiply. So what does that become? X to the 6th. And the reason is x squared to the third means how many x squareds do I have? I only heard one person answer.
3.
X squared to the third means I have how many x squareds?
3.
3. And we learned just a second ago that you add the exponents. What's 2 plus 2 plus 2? 6. Now, do you have to show this every single time? No. Just like you don't have to show this every single time. You know, here you add, you know, here you multiply, and you are good. All right, one observation I want you to make here is all the way across the bases stay the same. Do you see that? X, X, and the answer has a base of X. The exponents are changing. 2, 3 changes to 5 because you added them, but the X stayed X. Do you see that? Bases stay the same. All right, keep that in mind. This next one,
3.
3. X to the 8th over x squared. All right, this one will be another day, but this is still stuff we're going to review as well. X squared, or x to the 8th over x squared. What do I do? Do I divide? 8 divided by 2 is 4, so it's x to the 4th?
Yeah.
Yes.
I set it up purposely that way. The answer is no. Anybody remember what to do? Okay, what is it? X to the 6th. I heard 2 of you tell me that. Okay, what do you do?
Subtract.
Subtract. All right, so you subtract the exponents. Yes.
What I did is I wrote out all the x's and put it over.
Good job. Okay, so she expanded it because maybe you could remember the rule at first. Okay, so couldn't remember the rule at first, so she did this. Is that what you're saying? You expanded it? 1, 2, 3, 4, 5, 6, 7, 8, and it's over x squared. And then what did you do from there?
Crossed out 2 x's.
Crossed out 2 sets, and that leaves you with 1, 2, 3, 4, 5, 6, x to the 6th.
Why don't we just subtract?
That's what we have right here. Okay, so she's telling us how she remembered it. She didn't remember the answer, so she worked it out. So like these over here, do you have to show me this workout stuff every single time? No, this is just showing you how and why it works. I'm hoping you remember to add, remember to multiply, remember to subtract. Got it? Okay, number 4. This is just something, a fact you'll need to remember. X to the 0.
X.
I heard 0, I heard 1, I heard X.
1.
The answer is what? Are we good with that? Everyone understand that it's 1, why it's 1?
Yeah, why is it 1?
Why is it 1? Good question. What is x over x reduced to? Does everyone agree with that? What does 5 over 5 reduce to? 1. What are the powers? What if I threw a 5 squared over 5 squared? Is it still 1?
Yes.
Yeah, because that's 25 over 25 is still 1. Do you agree? We just talked about over here doing what with the exponents? When the bases are the same, you subtract. What's 1 plus 1? I'm sorry, I said it wrong. What's 1 minus 1 because we're subtracting? 0. So this is x to the 0. What's 2 minus 2? 5 to the 0. But we said originally, what was this answer? 1. And what was this answer? 1. So any base besides 0 raised to the 0 power is 1. Make sense?
Not really. But
0 to the 0 is undefined.
0.
0 to the 0 is undefined, but anything else raised to the 0 is 1. Yes. All right. Number 5. X to the negative 5th. We just reviewed this on Tuesday's lesson. What happens with negative exponents? It becomes a fraction. Good. So 1 over x to the what? X to the what? 5th. Positive 5. Okay, and the last one in the review section, number 6. This is similar to number 5. So this goes back to the question, Allison, was it you that asked earlier about do you always put a 1 when it moves? Okay, so this is one where you would not, and I'll show you why. All right. A common mistake kids make is anything that's negative, move to the bottom. So negative 3 goes down because it's negative, and x to the negative 2 goes down because the exponent's negative. Is that true? No. Only thing that moves are negative what? And that negative exponent is only attached to the x, not the negative 3. Do you see that?
Yeah.
All right? So a common misconception kids have is move everything. No, a few things. Only move what's attached with the negative exponent. And even though that's negative, is that a negative exponent? No. Should it move? No. So when you move the x to the negative 2 to the denominator, x to the positive 2, what stays in the numerator? Negative 3. So this would be the one where there's not a 1 left at the top. Make sense? Okay, so do not be tricked in thinking, oh, negative 3 is going down because it's negative. No, it's only when it's a negative what? Exponent. Good. Negative exponent moves, negative coefficient or negative base does not. All right, got it?
Got it.
Okay. New stuff. Examples. And I'm not really going to call it new stuff because it says still review. Number 1, negative 5x to the 3rd power times negative 3x to the 6th power. All right, what do you do with the bases? You multiply like terms. So negative, the coefficients, what's negative 5 times negative 3?
Positive 15x.
Positive 15. x3 and x6 give me x to the what?
18.
X to the 9, because we do what to the exponents?
Yeah.
Add them. All right, when is it that we multiply? When it's a power to a power, parentheses, exponent, exponent. All right, number 2. Seven to the 6th times 7 to the 5th. Okay, try it on your own.
still reviewing old stuff?
This is what you're going to be doing. This is what your examples are going to look like in homework, but it is review from last year. There's a slight twist of new stuff at the end of notes. Right now, we'll get you.
But I know it is.
What is it?
This isn't geometry, and I hate geometry.
It's not geometry.
Therefore, making me good at something.
All right. What do we end up with? Anybody get 49 to the 11th power?
Yep. No.
Don't, if you didn't, don't erase.
Oh, okay.
This is wrong. I purposely did it incorrectly.
Yeah, I got 7 to 11.
All right. What is the correct answer? 7 to the 11th power. Now, I did it purposely because sometimes kids do make this mistake. Anybody make it? You don't have to confess if you don't want to. Yes, good. All right. Now, listening. I bring it up because it's tempting to say, well, 7 times 7 is indeed 49. But remember when I pointed out over here, when you're multiplying like bases, what do you do with the exponents? And what did I say about the bases? The bases stay the same. X, X, X. So should the base stay 7? 7, 7, 7. Got it?
So, like, what if the bases were different?
Good question. If the bases were different, you couldn't do anything as far as adding exponents go. You'd have to simplify each one individually and go as far as you can go. But that's not going to happen for us today. And we will actually have some of the next lesson where the variables are different, and we'll talk about those. All right, questions on number 2. Okay, number 3. 5 to the 6th times 5 to the negative 2 times 5 to the negative 1. Okay, so the base is going to stay 5. Do you agree?
Yeah.
And then you do 6 plus negative 2 plus negative 1. Positive what?
3.
5 to the 3rd. And you don't need to simplify, just leave it like that. Questions? All right, next one. Negative 8n times 11n to the 9th. Negative 8n times 11n to the 9th. Okay, like,
I just asked you,
what?
what if the bases were different? You said we weren't going to deal with that.
The bases were different up here, 5, 3, x, x, n and n. The bases are the same. Just like this. You multiply the coefficients, so it's just like this one. What do we do with negative 8 times 11?
Negative 88.
Negative 88. And these bases are the same, so n to what power?
9.
N to, okay, I heard 2 different answers.
Oh, because that's 1.
Good, so which one is it?
10.
And why is that?
Because there's a secret 1.
There's a secret 1 there. If we don't see it, should we know it's there? Yes. All right. Got it? Questions? It's hard, you said? Okay. Who was that? Sounded very animated.
It sounded like that.
Sound like
All right, number 5. I want you to write your final answer, simplify in radical form. All right, so I want your final answer to be in radical form. Number 5. Bless you. 2 to the 1/7 times 2 to the 1/3. So this is where it's a little different from what you had last year. Okay. Are the bases the same? Yes, and they will be like this on your assignment today. We just did on the page before, if the bases are the same, what do you do with the exponents? Add them. Do not plug it in your calculator. You can do this. You can show your work right here. You learned this back in elementary school. What's your common denominator?
21.
Savage? I'll let you guys finish from there.
I got 1, 2, 3, 4, 5, 6, 7, 8. Bands in my bank account.
All right. What do I multiply top and bottom by on my first fraction? 3, so that becomes 3 over 21. This one top and bottom by, so 7 over 21. Add them up, and what do you get?
10, 21.
10 over 21. Only thing I ask is that you reduce if possible, but does 10 over 21 reduce?
No.
No. So 2 or 4 as the base. 2 raised to the 10 over 21. Now if I stopped here and said this is my answer, why would I get it wrong? I know. I'm not actually. I just haven't finished the last step. What? Just kidding. What form are they asking for? Radical form. Is this radical form or exponential form? So have I finished the problem? No. Radical 2, what goes right here? 21. And power?
10.
10. Does it matter if you put the power inside or outside?
Yep.
It does not. Final answer. All right. So if you stop there, would that be wrong? And you got that answer right here. Would that be wrong? Yes. You just haven't finished it. Radical form. All right. I'm going to let you try the next one on your own. Number 6. X to the 2/3 times x to the 1/4. Because the bases are the same, you can add the exponents. Go ahead and do that now. Can anybody tell me what the common denominator is?
12.
All right, what's the top fraction become? What do you multiply by?
Oh.
8/12?
Yeah.
And this one becomes, and you add them up, and that is 11/12. Can I reduce? Is 11/12 my answer?
Nope.
No, x raised to the 11/12. Is that my answer?
No.
No, radical form, x, what goes as the index?
12.
And the power,
11.
inside or outside, does it matter?
Nope.
That's it. All right. Okay. We're going to do the same type of problem, but instead of radical form, what do you think we're going to do? Write in exponential form. That's just a little easier because there's one less step. Do you agree? We could stop there, and that's the answer. All right. Number 7. 5 to the 2/9 times radical, it's the cube root of 5 squared. All right, this is different because we're going to leave it in exponential form, but there's one other difference with this second one here. What's different about it?
Sorry. Radical.
Okay, I want to be able to add the exponents. What will I have to do in this problem to be able to add the exponents?
Reverse.
Change this one to
Radical.
exponential?
Yeah.
All right, so 5 to the 2/9 times 5 to the what? 2/3. And what do you do with the, add them? I'm going to let you guys do that now. What's your common denominator? 9.
6.
I had, it's 9 or 27. If you did 27, you just have more reducing to do at the end. It's okay. It's not as easy as using 9, but it can be done. Does anybody have it added together already?
Yeah.
What did you come up with?
8/9.
8/9. Everybody agree?
Everything.
Okay, so double check it. All right, so this is 5 raised to what? Now, can I reduce the 8/9? Am I done here, or do I need to change it? Done, because this one is exponential form. So if I did change it to radical form, would I get it wrong? All right. Got it? We have a last piece. I'm skipping some because it was taking too long.
Genius.
Oh my.
Sheesh, Cole.
Fill in the blank. These are easy, so I'm not going to spend too much time here. 5 to the 3rd times 5 to the blank equals 5 to the 12th. Fill in the blank. Don't word it out. Just do it on your own.
This is pretty hard though.
This is
Dang it.
I already see Caleb's in.
Cole panicking, screaming. All right, anybody have it? 9. Why is it 9?
Because 3 plus 9 equals 12.
3 plus 9 is 12. Do you agree? Now, did you guys do that in your head? Yes? Now, technically, this is what you're doing, yes? 3 plus what number is 12? Subtracting 3. Now, you don't have to show that work, but do you agree that's what's going on?
I do.
Okay. So, when I give you one like number 2, that is x to the blank times x to the 7th equals x squared. I'm going to have you try that one on your own. No talking. Get to work.
Yes.
Yes. Okay.
It's negative 5.
All right, negative 5. Do you guys agree?
Yeah.
Why does it have to be negative?
Because a negative plus is, because negative plus positive equals positive.
In this case, it does, but not always. But because in order to get a positive to it, this would have to be a negative 5. Yes? All right. Again, if you showed you an equation, you would have x plus 7 equals 2, and what would you subtract from both sides? And would you end up with negative 5? All right. Are we good? Okay, last one. It's very similar, but the directions are different. Find the value of x. 5th root of 7 to the 3rd times 7 to the 1/5 equals 7 to the x over 5. I want you guys to try that one right now.
I think so.
Is this similar to the one we had on the other page where we have to change the 5th root problem? Yes, so we change it to what? 7 to the 3/5 times 7 to the 1/5 equals 7 to the x fifths. We're looking for x. What do we do here with these powers? What's nice about this addition? They already have a what? Common denominator. So what is it? 7 to the 4/5 equals 7 to the x fifth. Anybody have it? X equals 4. Right? What over 5 equals 4 over 5? Do you see that x is 4? Yes? And why does that work? Because the bases are the same. All right, questions?